We were talking about the use of LAN switches. The LAN switches permit to separate collision domains, permit to adapt different bit rates, permit to reach higher bandwidth aggregation traffic between different stations and servers. But there are other needs that LAN switches can't solve, and those, for instance, are typically in a local area network. Not all the stations need to exchange messages between all the other stations. Typically, there are different groups of stations that exchange a lot of information, and it would be interesting to perform some kind of logical segmentation into a unique physical LAN switched network. That could be performed by the implementation of another functionality that will be implemented within the switches, and that functionality is called VLANs, Virtual Local Area Networks. The VLANs, the virtual LAN, is a logical segmentation of the LAN, of the switched local area network, and this has some benefits that we could identify. The first is the broadcast control. In fact, the VLAN feature restricts broadcast, unicast, and multicast traffic to only the ports of the specific virtual LAN. In that way, we separate broadcast domains. Remember that without the use of VLANs, the switches don't separate broadcast domains, separates only collision domains. Then, separating broadcast domains, we avoid basically to misuse the network bandwidth in some links or ports that don't need that kind of broadcast messages, or even unicast and multicast traffic from other user groups of the network. The other benefit of the use of VLANs is based in the security that some messages need, for instance, to separate some groups of stations of nodes from the local area network, in order to avoid security issues, security problems that could happen in the network. Finally, other aspects that we need to understand is that the VLANs could be established according to different mechanisms. Typically, the most simple way to configure a VLAN is a port-based VLAN. It's very simple. Is a static configuration, typically a static configuration and is the first type of VLAN that could be configured in switching domain, the port-based VLAN. Other VLAN type is the MAC-based VLAN. That is, when we use the MAC address that is learned tied to each port, and based in that information in the MAC address, the switch configure each VLAN within the switching domain. And there are other types of VLANs. For instance, VLANs configured in a protocol-based VLAN method. And then, for instance, using a layer 3 protocol or a higher layer 3 protocols, for instance, authentication protocols. In the case of port-based VLANs, this is the most simple way to configure a VLAN. It's a static method, and within each of those switches, the switch administrator has to configure which port is member of which VLAN. In fact, even some ports could be used as trunk ports. That is, those ports transport frames from different VLANs, and in that way we will see a particular protocol used over those links. That is the 802.1q protocol. That is a tagging protocol in order to indicate to which VLAN pertain some messages, some frame that is transmitted over the uplink or trunk link. But if we talk about the port-based VLAN configuration, in fact, there is a table that must be configured within each switch, where we configure which are the ports that are members of each VLAN. For instance, in this case, for the VLAN 1, for instance, those are the ports members of the VLAN 1. In the case of the VLAN 2, for instance, those are the ports of this VLAN. And finally, for instance, in the case of the VLAN 3, those are the ports of the VLAN 3. In that way, we could perform logical segmentation, a very simple logical segmentation of the local area network. If we recall that this means that, for instance, if a station transmits a frame or a broadcast frame over this port, this broadcast frame will be forwarded to the other switches and will be forwarded to this port and this port. But that broadcast frame will not be forwarded to the other ports of the VLAN domain, of the VLAN switching domain. And even if, for instance, in this this station send a unicast frame, but the destination of the unicast frame is not already learned by this switch and the other switches, then in fact it will be the typical unknown frame, and in this case this unknown frame will be forwarded to all the other ports of the same virtual LAN. That is, that frame will be forwarded only to this port, this port, and this port, and this port. This is, in fact, the way that the VLAN functionality of the switches could perform a logical segmentation of the network. In the case of use of MAC-based VLANs configuration, this is a typical dynamic method of VLAN configuration. Then, in this case, the switches configure the VLANs using the MAC addresses of the stations that are connected to each port. Remember that each switch learns where this MAC address is located, because the switch perform a learning functionality that examine the source address of each frame exchange across the network. Then, for instance, in this case, the VLAN is configured based in the MAC addresses. Then, for instance, in this way, the VLAN 1 will be configured where those ports associated with those MAC addresses are in this VLAN 1. For instance, this is the port where this MAC address is learned. This is the port where this MAC address is learned. This is the port where this MAC address is learned, and those are the other ports where those MAC addresses are learned. In that way, the VLAN 1 is configured dynamically using the learning process of the switches. Finally, we could use protocol-based VLANs that is more complex or more sophisticated VLAN configuration methods. For instance, using an authentication protocol like this one. This is an IEEE 802.1x protocol. And this is a protocol that uses the Extensible Authentication Protocol, EAP, and this is the protocol exchange between any LAN station and the switch. And in this case, this is a protocol called Extension Authentication Protocol over LAN. And then the station that would like to access the network dialog using this protocol is a layer 7 protocol, and in using this extension authentication protocol, the switch could authorize or not the access to this user, and if this user is authorized to access the network, the switch will associate this station where this user is logged in to a particular virtual local area network. In order to know which are the credentials and the verificators in order to authenticate the client, the user, the switches typically use another protocol, another layer 7 protocol called, for instance, Radius. Radius comes from Remote Authentication via Link User Service. And in this way, we could use a centralized database that contain all the information related with each authorized user of the network. And then in some scenarios, typically when we use the uplink or trunk links, we need to exchange over those segments frames from different VLANs. Then what is important is to identify each frame with the corresponding VLAN. This is accomplished using this protocol or this standard called IEEE 802.1q, and is a protocol that insert 32 bits between the address, the MAC address of the frame, and the type or length of the frame, depending if it's an Ethernet 2 frame or an IEEE 802.3 frame. In that way, the frame could be identified with the VLAN, the corresponding VLAN. The format of those 32 bits is this one, where the first 16 bits are used with a fixed number, that is the 8100 in hexadecimal notation, and this number permits that the receiving entity identify that this is a 802.1q frame, and not an Ethernet 2 or a 802.3 frame. After that, at the end of the 32 bits, we could use 12 bits to identify the VLAN with this 12 bits number. Then we could identify more than 4,000 different VLANs using this protocol. We could use other type of VLAN trunking protocol, for instance, the ISL, the Inter-Switch Link Protocol, but in that case is a proprietary Cisco protocol that could be used only between switches and routers, but from Cisco. Then we could use ISL if this is a Cisco router and this is a Cisco switch in order to exchange multiple different VLANs over and that kind of uplinks or trunks. And well, finally, there are other bits used in the tagging field, and one of those is the class of service in order to specify some kind of quality of service requirement. Where, for instance, if all those 3 bits are in 0, means that we don't need any preferential treatment for this frame. Or, for instance, if those 3 bits has the number 5. That means that this frame require the highest priority. And for instance, there are another bit, the drop eligible indicator or canonical frame indicator, that could be used to indicate that that frame could be discarded if congestion situation occur in the network. Finally, remember that in fact the 802.1q is based in the insertion of the 32 bits between the MAC address, the source MAC address, and the length in the case of 802.3 frame, or the type in the case of Ethernet 2 frame. And because we use this number in these 16 bits, the receiver of this frame could understand that this is not a 802.3 frame nor a Ethernet 2 frame. Why? Because this number is higher than the typical MTU of Ethernet, that is 1,500 bytes, and this number is different from the typical frame type of Ethernet 2.